Alright guys, lesson 5-2 is called direct variation, and it's just another type of graph. It's a different type of equation. So the objective here is going to be to write and graph an equation of a direct variation. Okay, so I think this one starts out with the getting ready box here is actually a really good example to kind of help you understand these direct variations. So if you look on page 301, it says the diagram shows how long it takes to hear thunder after you see lightning. What general rule can you use to model this situation? So in the picture, they have that if you are 2 miles away, you will hear it in 10 seconds. Okay, and then on the other side, they have if you're 3 miles away, you will hear it in 15 seconds. Okay, so it says, what general rule can you use to model this situation? Well, what's happening here is you need to find the unit rate. If you remember talking about those last year, if you're 2 miles away, that's 10 seconds. And if you're 3 miles away, that's 15 seconds. We'll try and generalize it. What if you were only 1 mile away? Okay, so 2 miles away is 10 seconds. So 10 divided by 2, that's 5. Okay, 3 miles away is 15 seconds. So 15 divided by 3, that's also 5. So the unit rate would be 5. It takes you 5, and each time we did seconds divided by miles. So it's 5 seconds per mile. So what you do is when you hear thunder, you start counting until you see the lightning strike. And then every 5 seconds that you count, that's another mile away. So that's what this is that's a direct variation. The number of seconds it takes until you hear, from when you hear the thunder to see the lightning, varies directly with the number of miles. It's not like once you get to 5 miles away, all of a sudden like it doubles or something. It's going to be 5 seconds per mile for as short amount of miles as 1 to as many as forever. Okay, so the two variables are varying directly. Okay, so the vocabulary here, we have a direct variation. Okay, if the ratios of two variables is constant, like our two variables that we just had were distance in miles and time in seconds. So our two variables is constant. Both times it was 5. Okay, that's how you know it's a direct variation. Now, the relationship can be represented by the equation y equals kx. Okay, so this is another equation that you're going to have to memorize. If I say what's the equation for a direct variation, you have to be able to say y equals kx. Now, k can't equal 0, because if it equals 0, then anything times 0 is just 0, and you have this equation, y equals 0, and that's just a flat line going through the y-axis like this. So that's the only number that k can't equal, and it doesn't make sense because what real-life situation are you going to multiply by 0? You wouldn't really even have an event happening if you're multiplying by 0. Okay, the variable k, so x and y is just because you have an x and a y axis. Every equation that we're going to have is going to have an x and a y. But the k here, that's called the constant of variation. You can put this here now. It's also going to be called the slope. We'll get to that in a little bit. But it's called the constant of variation because if the ratio of the two variables is constant, whatever that constant value is, like with the thunder and the lightning, the constant was 5. So the constant variation was 5. The equation for that example we just did would be y equals, the constant of variation was 5, and then x. So whatever value you put in for x, whatever amount of miles you want to be away, you would multiply it by 5. Well, no, however much time you count, how many seconds, you multiply it by 5, and that's how many miles you are away. Okay, so these equations are pretty simple. Alright, I have these two examples, and these aren't from the book, but it kind of helps you just visually see the difference between when you have a direct variation and when you don't. So this table here, it's just for a certain car, the number of miles you get per gallon. Okay, so if you drive 72 miles, you will use 4 gallons of gas. Okay, if you drive 144 miles, you will use 8 gallons, and if you drive 216, you will use 12 gallons. Okay, this is a direct variation because you got to figure out how many miles per gallon. So if you can figure out a number that you're multiplying by, okay, so miles equals some number times the gallons. If you can figure that out and it's the same number each time, it's a direct variation. Now, I don't know what number you're multiplying by, so sometimes when you don't know what number you're multiplying by, it's easier to divide. So if you take 72 divided by 4, you get 18. If you take 144 divided by 8, you get 18. And if you take 216 divided by 8, you get 18. So each time, you're taking the number of gallons and you're multiplying it by 18. That's a direct variation. You're just multiplying by 18 each time. Okay, so this one is a direct variation. Now this one, Mochi the panda cub has been measured and weighed each week since she was born. Okay, so here's your table. Now, right here, this kind of gives it away. Can't be a direct variation, but let's say we tried something. Okay, remember when we were trying to write equations like y equals something something, so right here, we could try times by 5, because 1 times 5 would be 5. But that doesn't work down here, because 2 times 5 is not 9, and 3 times 5 is not 13. So it's definitely not a direct variation, because you're not just multiplying by some constant. If we were to write an equation for this, since I see this 0 and the 1, I know whatever I multiply 0 by, I'm going to have to add 1. So what did I multiply by, and then add 1, and get 5. I think it's 4x plus 1. Okay, it's not a direct variation because you have this extra piece. Remember, the formula for direct variation is y equals kx. There is no plus or minus at the end. Okay, so first you want to see, like from a table, if it varies directly. And then another thing, if we were to graph this, I mean, don't you think if you use 0 gallons of gas, so if we extended this table backwards, instead of 4 gallons, if we drove 0 gallons, how many miles would we go? 0. Like, direct variations will always start at the origin, because if you have 0 gallons of gas used, then that's going to equal 0 miles. But right here, when it was born, at 0 weeks, it was already 1 pound. Okay, so that's kind of the difference. Direct variations have to go through 0, 0. This is going to be a different type of equation. Okay, and we'll get to those. That's, I think, the next chapter. Okay, so problem 1 says identifying a direct variation. Now, there's no table here, no word problem. It's just 2 equations. So, does the equation represent a direct variation? If so, what's the constant of variation? So, you have to know the formula for direct variation. Y equals kx. So every formula that's a direct variation is solved for y. So we need to take this equation, 7y equals 2x, and we need to solve it for y and see if we get a direct variation. Well, the only thing we need to do to solve for y is just divide both sides by 7. So we have y equals 2 over 7 x. And yeah, that's a direct variation. It doesn't say there's anything wrong with having a fraction. So, yes, this is a direct variation. Okay, if so, what is the constant of variation? The constant of variation is just this right here, the k value, the number that comes in front of x. So, the constant of variation is 2 over 7. Okay, part B, we have 3y plus 4x equals 8. If it's going to be a direct variation, we need to solve it for y and see what it looks like. So, to solve this for y, this is going to be the last thing. You have to you have to keep y on the left side, and you have to move the whole other variable piece to the other side. So subtract 4x from both sides. This is like those literal equations we had to do when you had to work with variables. Now you can't do 8 minus 4x because 8 is just a term, 8 is a constant, and the negative 4 has a variable on it. So you just leave it as 8 minus 4x. Then to solve for y, you divide both sides by 3. And don't even worry about figuring out what this is. Is it going to be a direct variation? No, because you have this extra 8 over 3 part. So anytime you see, like from the beginning, if you see you have more than just 2 parts, pretty much it's not going to be a direct variation if you have, because when you solve it, then you're going to have something extra. Okay, so direct variations are just y equals some number times x. You can't have an extra piece out here. And if it's not a direct variation, you can't have a constant of variation. So this 4 over 3 really means nothing. Okay, problem 2, writing a direct variation from an equation. So this says, suppose y varies directly with x. As soon as it tells you that, you know you have this. Y equals kx. You're not trying to check to see if you have that. It says suppose y varies directly with x. So you know you have that formula. Okay? And then it tells you y is 35 and x is 5. What's the direct variation that relates x to y? So think about it. If they vary directly, what are you doing to the x value of 5 and coming out with 35? Okay, if you can just think about it, you're multiplying by 7. Okay, so eventually we're multiplying by 7, which means the constant of variation is 7. But as these get harder and not so obvious, like maybe decimals, what you do is if you know you have a direct variation, you write down the formula. Okay, it says y is 35. So I'm going to put 35 underneath the y. You don't know what k is. I mean, in this case, we know it's 7, but pretend you don't know. And then x is 5. Now you just solve this equation for k, divide both sides by 5, and you get 7 equals k. Okay, so your equation, which we already knew, was y equals 7x. Okay, so they vary directly. You take the x value, multiply it by something specific, and you get the y value. So then the second part of this says, what is the value of y when x equals 9? Well, if x equals 9, they just want us to do 7 times 9, and that's 63. Okay, so you just got to watch. Are they asking you to check if something's a direct variation? You have to solve the equation. If they're telling you it is, by saying suppose, it is a direct variation, you know you can start with that formula. Okay, a couple things you definitely want to write down about graphs. We're not going to do problem 3 because it just asks you to do a graph, but there are some specific things. It's always going to pass through the point 0, 0. Because remember, like the one with the gasoline and the miles, if it's a direct variation, anytime you multiply by 0, you should get 0. So you should have a 0, 0. And then whatever you go up by, maybe 3 each time, or 5 each time, but it has to go through 0, 0. And then the k, when you have this formula, so let's say y equals 5x, k is your slope. So we would be going up 5 over 1, up 5 over 1. Or it could be a fraction. Okay, so problem 4 is writing a direct variation from a table. So it says, for the data in the table, does y vary directly with x? So it's asking you. So you can't start by saying y equals kx because it's asking you that, okay? We're trying to figure out whether it does, if it doesn't. If so, write the equation. If not, then you just say it's not a direct variation. So we need to figure out, am I taking the same number, multiplying the x column by it, and getting the y column? So I don't know what you multiply 4 by to get 6, but if you don't know, you just use division. So we're going to take each of these pairings, 6 divided by 4, 12 divided by 8, and 15 divided by 10. Okay? If those are all the same, then we have a direct variation. So 6 divided by 4 is 1.5. 12 divided by 8 is 1.5. And 15 divided by 10 is 1.5. Okay, that right there means you have a direct variation. If you would work this table backwards, you would eventually have the ordered pair 0, 0. Okay, because 0 times 1.5 is 0. So, if so, write an equation for the direct variation. Well, this right here, this is your constant of variation. That's what you're multiplying by each time. So your equation is just y equals 1.5x. Okay, so for the second one, we're going to do the same thing. We're going to take the y value, and now I don't know what you take negative 2 by to get 3.2, so I'm just going to use division. 3.2 divided by negative 2. 2.4 divided by 1, and 1.6 divided by 2.4. Now, I'm not even going to do these, because right here, a positive divided by a negative is going to be a negative number. And then here, a positive divided by a positive is going to be a positive. And for the third one, a positive divided by a positive is going to be a positive. So there's no way those three can all turn out to be the same number. Because even if over here on the left, if one of those would have been a negative 1.5, those are two completely different numbers. So this one right here, you would just say not a direct variation. Doesn't mean you can't write an equation for it. It's just going to involve more than just multiplying by a number. Okay, and that's it. So check out the lesson check on page 304. There's 8 questions. We'll go over them tomorrow at the beginning of class.